Hey everybody, this is Mr. Beckstrom, and today I'd like to go over how we can apply the rational root theorem in order to find factors of a polynomial. Usually we're just going to do it when they're third degree or higher because we have already lots of tools such as the quadratic formula to do those that are squared as being the highest. So anything that's cubed or higher, usually we want to use some type of method, either Descartes' rule of signs to help us narrow them down, or the rational root theorem. So here we're going to use the rational root theorem, and here's what the rational root theorem says. It says that if we have any polynomial, if it contains any rational root, that means a value that makes this equal to 0, and rational is a number that can be written as an integer divided by an integer, then it will show up when we use this method here. So here's how we do the method. Let me go ahead and pull out my pen here. All right, and what I want to do is I want to call this over here Q. This will be the coefficient that's in front of the first term here, so that's really just going to be a 1 since we don't see anything here. And then we're going to call the last number, that's the number without any x's attached to it, it's also called the constant. We're going to make that P. Now how we set this up is we take all of the factors of the last number here. So here's the numbers that can go into 6 or -6. So plus or minus 1, plus or minus 2, plus or minus 3. Make that plus a little bit better. And plus or minus 6. So that's 12 different possibilities for the factors of -6 here for the last one. And then what we're going to do is we're going to take all those factors and put them over each factor of the first term, which is that 1. And so for 1, we just have plus or minus 1. So we're going to look at each one of these numbers over each one of these numbers, which is just going to give us these 4 right here, divided by this, which just makes them the same. So here's what we're going to do. We're going to pull out our calculator, make this a little bit easier. Oops. Let's see if I can, all right, let me see what that was. That's x cubed minus 2x squared. So x cubed minus 2x squared. Let me bring that up again here. And that's plus 3x minus 6. Plus 3x minus 6. Now we're going to go to our second window, which is our table set. Make sure this independent is on ask. If it's not on ask, you need to highlight it and hit enter. And then we're going to go to our table, which is under second graph here. And let me go ahead and delete these. And what we're doing is the rational root theorem says that if we put this value in there and it gives us a 0 for our y value, then we know that that's a root. All right, so let's check 1, -1. So far, no good. 2. There we go. So that's one of our roots. Let's see if we can find the other roots. Now, they may not end up being rational numbers or even real numbers at that, but we can check just since this is pretty quick. And then 3, -3, and 6, or -6. All right, so the only value that came through is 2. And remember, with the third degree polynomial, we're going to have 3 complex roots. So that means my other 2 roots are either going to be irrational, like a square root, or they're going to be imaginary with the I. So let's see which ones those are. So going back to here, what we're going to do is we're going to use synthetic division on the 2. Once again, That 2 gave us 0. So to do synthetic division, we put the 2, and then we put all the coefficients of our third degree polynomial here, which is going to be 1, -2, 3, and -6. Just like this, all the coefficients there. We bring down the 1. 2 times 1 is 2. Add those together, you get 0. 0 times 2 is 0. Add that together, you get 3. 2 times 3 is 6. Add that together to get 0. So the last one should always come out 0 here, which means that our new polynomial that's going to be 1 degree less than our original is going to have the coefficients of 1, 0, and 3. So since it's one exponent less, this is going to be a 1x squared, which is just x squared. There's going to be no x term, and then it's going to be a plus 3. Plus 3. So we can put that factor with the one that we already got with the 2. Remember, a root of 2 corresponds to the factor x minus 2. It's always the changing the signs there. So we can now factor it into this form here. And now we just need to find the factors for this one here. So let's just go ahead and look at that alone. All right, so that's going to be x squared plus 3 is equal to 0. X squared is equal to -3 after we subtract 3 from both sides and then take the square root. And we're going to get x is equal to plus or minus the square root of -3. And don't forget, you can pull the negative outside of the radical by putting an I out there. So this is just going to be plus or minus I times the square root of 3. And those are our two final roots. So that would be positive I root 3 and negative I root 3. All right, guys, I hope this helped. If you have any questions, let me know, and have a great break. Thanks.